So two charges Q1 and Q2 are placed 30 centimeter apart. So this is a Q1 and Q2 are placed 30 centimeter apart as shown in figure. A third charge Q3 is moved along the arc. So this is the arc, along the arc of radius 40 centimeter from C to the D. From C to the D, the change in the potential energy of the system is given. Okay, ಹಾಗಾದ್ರೆ change in potential energy is equal to how much? This is the change in potential energy is equal to Q3 divided by 4 pi epsilon naught K. So where K is what anta kelidane. So ಹಾಗಾದ್ರೆ let's see the solution for the problem. So ಹಾಗಾದ್ರೆ what is the potential energy? The potential energy at the potential energy when Q3 is at C position. Okay, Q3 is C position. What is the potential energy? So this is the potential energy. U1 is equal to K is common. So Q1 Q3 divided by distance is 0.40 plus Q1 Q2 divided by distance is how much? So this is the distance. So what is this distance? So the distance of this one. Okay, so this distance is equal to how much? Square root of 0.40 square plus 0.30 square. Okay, so this is Q1 Q3 and Q3 Q2. Okay, Q3 Q2. So next so you have to, when the potential energy when Q3 is at, okay, Q3 is at what point? D point alli iddaga. Hagadre U2 is equal to K into, so where Q3 is what position? Q3 is here. So then Q1 Q3 divided by, so what is the overall distance? Overall distance is equal to 0.40 meter, because it is a what? It is a radius. Hagadre this much, 0.40 meter. So this is centimeter is there. Meter cannot madidini ashte. Okay, hagadre plus Q2 Q3 divided by, what is this distance? So 0.40 ಒಳಗೆ 0.30 ಹೋದರೆ 0.10 meter. 0.10 meter. So now this is called as the U2. ಹಾಗಾದ್ರೆ change in potential energy. Change in potential energy is equal to U2 minus U1. ಹಾಗಾದ್ರೆ change in potential energy is how much? Q3 divided by 4 pi epsilon naught into K is equal to, so U2 is what? K into Q1 Q3 divided by 0.40 plus Q2 Q3 divided by 0.10, then minus sign Q1 Q3 divided by 0.40 minus Q3 Q2 Q3 divided by, so square root of 0.40 square plus 0.30 square. So now you have to do the calculation. K get cancelled. So nodi enen cancel agutte anta. So K get cancel. Hagadre Q3 nodi Q3. So this Q3 is cancel. ಸೊ ಹಾಗಾದ್ರೆ ಏನೇನು ಉಳಿಯುತ್ತೆ, ಸೊ ದಿಸ್ ಬಿಕಮ್ಸ್ ಫೈನಲ್ ಆಗಿ ಏನು ಉಳಿಯುತ್ತೆ ಇಲ್ಲಿ, ಸೊ ದಟ್ ಈಸ್ 1 divided by 4 pi epsilon naught. ಓಕೆ, ಹಾಗಾದ್ರೆ ಸೊ ವೇರ್ ಕೆ ಅಂತ ಕೇಳಿದಾನೆ ಅಂದ್ರೆ, ಸೊ ದಿಸ್ ಇಸ್ ನಾಟ್ ಎ ಕಾನ್ಸ್ಟೆಂಟ್. ಕೆ ಮೀನ್ಸ್ ವಾಟ್, ದಿಸ್ ಇಸ್ ಎ 1/4 pi epsilon naught. ಸಾರಿ, ಓಕೆ, ಹಾಗಾದ್ರೆ ಈ ಕೆ ನ ಕಂಡುಹಿಡಿಯಬೇಕಾಗಿದೆ. 1/4 pi epsilon naught. ಹಾಗಾದ್ರೆ ದಿಸ್ 1/4 pi epsilon naught, ದಿಸ್ 1/4 pi epsilon naught ಏನಾಗುತ್ತೆ ಇಲ್ಲಿ, ಕ್ಯಾನ್ಸಲ್. ಓಕೆ, ಸೊ ಹಾಗಾದ್ರೆ ದೆನ್ ಸೊ ಇಲ್ಲಿ Q3 1/4 pi epsilon naught ಕ್ಯಾನ್ಸಲ್. ಹಾಗಾದ್ರೆ K is equal to, so this one Q divided by 0.40, Q1 divided by 0.40 cancel. So remaining ಏನು ಉಳಿಯುತ್ತೆ ಅಲ್ಲಿ, Q2 divided by 0.10 minus, okay, minus this one Q2 divided by ಇಲ್ಲಿ. ಸೊ ಇದನ್ನ ಸಿಂಪ್ಲಿಫೈಡ್ ಮಾಡಿದಾಗ ಎಷ್ಟು ಬರುತ್ತೆ ಆನ್ಸರ್, ಸೊ ದಿಸ್ ವಿಲ್ ಬಿ, ಟು ಗೆಟ್ ದ ಆನ್ಸರ್ ಈಸ್ ಈಕ್ವಲ್ ಟು 0.5 ಬರುತ್ತೆ. 0.5. ಸೊ ನಾವು ಈಗ Q2 ಅನ್ನ ಕಾಮನ್ ತೆಗೆದ್ರೆ, ಓಕೆ, Q2 ಅನ್ನ ಕಾಮನ್ ತೆಗೆದ್ವಿ ಅನ್ಕೊಳ್ರಿ. ಸೊ Q2 ಅನ್ನ ಕಾಮನ್ ತೆಗೆದ್ರೆ ಎಷ್ಟು ಬರುತ್ತೆ, 0.10 minus 0.50. This is 0.10, 0.50. So K is equal to, so what is the answer for K? K is equal to 4Q2 divided by 0.50. So now the answer is 8Q2. Okay, option C is the right answer for the 21 question. 22 question ಗೆ ಹೋಗೋಣ ನೋಡಿ. 22 question ಏನಿದೆ, identical charges minus q are placed at the each corners of the cube of side B ಅಂತ ಕೇಳ್ತಾನೆ. ಓಕೆ, ಹಾಗಾದ್ರೆ ಫಸ್ಟ್ ಗೆ ಯು ಹ್ಯಾವ್ ಟು ಡ್ರಾ ದಿ, ಓಕೆ, ಕಾರ್ನರ್ ಅನ್ನು ಹಾಕೋಣ. ಓಕೆ, ಸೊ ದಿಸ್ ಇಸ್ ಎ, so cube, ಓಕೆ, ಹಾಗಾದ್ರೆ ಸೊ ಈ ಕ್ಯೂಬ್ ನಲ್ಲಿ ಏನು ಹೇಳ್ತಾ ಇರ್ತಾನೆ, ದ ಚಾರ್ಜ್ ಮೈನಸ್ ಕ್ಯೂ ಈಸ್ ಪ್ಲೇಸ್ ಅಟ್ ದ ಈಚ್ ಕಾರ್ನರ್. ಸೊ ಮೈನಸ್ ಕ್ಯೂ ಚಾರ್ಜ್ ಅನ್ನ ಪ್ಲೇಸ್ಮೆಂಟ್ ಮಾಡಿದೀನಿ ಅಂತ ಹೇಳ್ತಾನೆ. ಮೈನಸ್ ಕ್ಯೂ ಮೈನಸ್ ಕ್ಯೂ ಮೈನಸ್ ಕ್ಯೂ ಮೈನಸ್ ಕ್ಯೂ ಮೈನಸ್ ಕ್ಯೂ. ಓಕೆ, ಹಾಗಾದ್ರೆ ಏನು ಹೇಳ್ತಾನೆ, ಸೊ ಸೈಡ್ ಬಿ. Then electrostatic potential energy charge Q which is placed at the center. ನೋಡಿ, ಸೆಂಟರ್ ನಲ್ಲಿ ಪ್ಲಸ್ ಕ್ಯೂ ಚಾರ್ಜ್ ಅನ್ನು ಇಟ್ಟಿದ್ದೀನಿ ಅಂತ ಹೇಳ್ತಾನೆ. ಹಾಗಾದ್ರೆ ಸೊ ಏನ್ ಕ್ವಶನ್ ಅನ್ನ ಕೇಳಿದಾನೆ, ಎಲೆಕ್ಟ್ರೋಸ್ಟಾಟಿಕ್ ಪೊಟೆನ್ಷಿಯಲ್ ಎನರ್ಜಿ ಎಷ್ಟು ಅಂತ ಕೇಳಿದ್ದಾರೆ. ಎಲೆಕ್ಟ್ರೋಸ್ಟಾಟಿಕ್ ಪೊಟೆನ್ಷಿಯಲ್ ಎನರ್ಜಿಯನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಕ್ಕೆ ಹೇಳಿದ್ದಾರೆ. ಓಕೆ, ಹಾಗಾದ್ರೆ ನೋಡಿ, ಸೊ ದಿಸ್ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಎ ಡಯಾಗೋನಲ್. ಓಕೆ, ಹಾಗಾದ್ರೆ ಈ ಡಯಾಗೋನಲ್ ಎಷ್ಟಿರುತ್ತೆ, ಓಕೆ, ಯಾಕಂದ್ರೆ ಡಯಾಗೋನಲ್ ಅನ್ನ ಡಿವೈಡೆಡ್ ಬೈ 2 ಮಾಡಿದಾಗ ಈ ಡಿಸ್ಟೆನ್ಸ್ ಸಿಕ್ಬಿಡುತ್ತೆ. ಹಾಗಾದ್ರೆ ಡಯಾಗೋನಲ್ ಆಫ್ ದ ಕ್ಯೂಬ್ ಇಸ್ ಈಕ್ವಲ್ ಟು, ಓಕೆ, ಯಾಕಂದ್ರೆ ಪೊಟೆನ್ಷಿಯಲ್ ಎನರ್ಜಿ ಬೇಕಪ್ಪ ಅಂದ್ರೆ ನೋಡಿ ಇಲ್ಲಿ, ಸೊ ಪ್ಲಸ್ ಮೈನಸ್, ಓಕೆ, ಸೊ ಪ್ಲಸ್ ಮೈನಸ್ ಎಲ್ಲ ಕಡೆಗೂ ಈ ಕಡೆ ಎಷ್ಟಿದಾವೆ ಟೋಟಲ್ ಆಗಿ ನೋಡಿ, 4 + 4 8 ಕ್ಯೂಬ್ಸ್, 8 ಸೈಡ್ಸ್ ಗಳು ಬರ್ತವೆ. ಹಾಗಾಗಿ ಈಸಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬಹುದು. ಹಾಗಾದ್ರೆ ಡಯಾಗೋನಲ್ ಆಫ್ ದ ಕ್ಯೂಬ್ ಎಷ್ಟಿರುತ್ತೆ, ಡಯಾಗೋನಲ್ ಆಫ್ ದ ಕ್ಯೂಬ್ ಇಸ್ ಈಕ್ವಲ್ ಟು, ಓಕೆ, ಸೈಡ್ ಎಷ್ಟು ಹೇಳ್ತಾನೆ, ಬಿ ಸ್ಕ್ವೇರ್. ಹಾಗಾದ್ರೆ ಬಿ ಸ್ಕ್ವೇರ್ ಪ್ಲಸ್ ಬಿ ಸ್ಕ್ವೇರ್ ಪ್ಲಸ್ ಬಿ ಸ್ಕ್ವೇರ್ ಅಂದ್ರೆ, ಸೊ ದಟ್ ಈಸ್ √3b ಇರುತ್ತೆ. ಸೊ ಹಾಗಾದ್ರೆ ನೋಡಿ, ಈ ಡಯಾಗೋನಲ್ ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ಡಿಸ್ಟೆನ್ಸ್, ಸೊ ಈ ಡಿಸ್ಟೆನ್ಸ್ ಎಷ್ಟಿರುತ್ತೆ, ಸೊ ದ ಡಿಸ್ಟೆನ್ಸ್ ಫ್ರಮ್ ದ ಸೆಂಟರ್, ಓಕೆ, ಸೊ ಡಿಸ್ಟೆನ್ಸ್ ಫ್ರಮ್ ದಿ ಪ್ಲಸ್ ಕ್ಯೂ ಇಂದ ಎಷ್ಟಿರುತ್ತೆ, √3/2b ಇರುತ್ತೆ. ಓಕೆ, √3/2b. ಹಾಗಾದ್ರೆ ನಾವು ಪೊಟೆನ್ಷಿಯಲ್ ಎನರ್ಜಿ ಫಾರ್ ಈಚ್ ಒಂದ್ರ ಕಂಡಿಡಿಯೋಣ. ಫಸ್ಟ್ ಒನ್, ಸೊ ಪೊಟೆನ್ಷಿಯಲ್ ಎನರ್ಜಿ ಫಾರ್ ದ ಈಚ್, ಸೊ ಈಚ್ ಪೊಟೆನ್ಷಿಯಲ್ ಎನರ್ಜಿ ಎಷ್ಟಿರುತ್ತೆ ನೋಡಿ ಇಲ್ಲಿ, ಸೊ ಕ್ಯೂ ಅನ್ನ ಪ್ಲೇಸ್ಮೆಂಟ್ ಮಾಡಿದ್ದಾನೆ. ಹಾಗಾದ್ರೆ ಏನಾಗುತ್ತೆ ಪೊಟೆನ್ಷಿಯಲ್ ಎನರ್ಜಿ ಪ್ಲಸ್ ಕ್ಯೂ ಮೈನಸ್ ಕ್ಯೂ, ಓಕೆ, ಪ್ಲಸ್ ಕ್ಯೂ ಮೈನಸ್ ಕ್ಯೂ ಡಿವೈಡೆಡ್ ಬೈ 4 pi epsilon naught 1 by 4 pi epsilon naught q1 q2 divided by distance ಎಷ್ಟಿದೆ ಡಿಸ್ಟೆನ್ಸ್ √3 by 2b. ಸೊ ಹಾಗಾದ್ರೆ ನಾವು 2 minus q square, so minus 2q square 4 pi epsilon naught √3b ಇರುತ್ತೆ. ಸೊ 2 1 ಜಾ 2 2 ಜಾ. ಸೊ ಹಾಗಾದ್ರೆ ಟೋಟಲ್ ಆಗಿ ಎಷ್ಟಿದಾವೆ 8. ಸೊ 8 ಆದರೆ 8 ಇಂಟು ಮೈನಸ್ ಕ್ಯೂ ಸ್ಕ್ವೇರ್ ಡಿವೈಡೆಡ್ ಬೈ 2 ಪೈ ಎಪ್ಸಿಲಾನ್ ನಾಟ್ √3 ಇಂಟು ಬಿ. ಸೊ ಹಾಗಾದ್ರೆ ಆನ್ಸರ್ ಎಷ್ಟು ಬರುತ್ತೆ? ಸೊ ದಟ್ ಈಸ್, ಸೊ 2 4 ಜೆ ಕ್ಯಾನ್ಸಲ್ ಆಗಿ ಮೈನಸ್ 4q ಸ್ಕ್ವೇರ್ divided by √3 pi epsilon naught b. Okay, epsilon naught b. So which is the right answer? Minus 4q square √3 pi epsilon naught b. That is a option C is the right answer. Okay, so option C is the right answer for 22. So 23 question. Nodi 23 question. In bringing an electron towards another electron, the electrostatic potential energy of the system. So this is a minus charge is here. To bring the another charge is minus. So minus minus means which type of force? That is a electrostatic repulsive force. Because of due to electrostatic repulsive force, that is a work is done. Okay, the work is done. The work done is more. So the work done is more means what is a potential energy? Potential energy is storage of the work done is the storage of what? Potential energy. Work done is more, potential energy is also more. So which is the right answer? The potential energy of the system is increases. Option B is the right answer for 23. 24th question. Potential energy in the external electric field. An electric dipole of dipole moment P is aligned parallel to the uniform electric field. So let's see, this is called as a uniform electric field. However, in this uniform electric field, you have to place what? Dipole. Okay, so this is called as a what? This is the dipole. So this is a minus q charge, this is a plus q charge, this is the direction of the dipole, this is the electric field. Theta is equal to how much? 0 degree. The energy required to rotate the dipole 90 degree. Theta 1 is equal to 0, theta 2 is equal to 90 degree. However, what is the work done? Question is, okay, however, work done is equal to, so nodi, the energy required to rotate, energy is equal to, so what is the formula? Minus PE, that is cos theta 2 minus cos theta 1. That is potential energy is equal to minus PE, what is cos 90 degree minus cos 0 degree. The potential energy is equal to minus PE cos 90, 0 minus 1. So minus into minus plus, that is a PE. That is a option B is the right answer for 24th. So let's move to the question number 25. So 25 question anna nodi. An electric dipole of dipole moment P is placed in the electric field intensity E. The dipole acquires the position such that axis of the dipole makes an angle theta with the direction of the field. So first one, you have to draw the electric field. So this is called as the electric field. So in this electric field, you have to take the dipole. Okay, so this is called as a dipole minus q plus q. How the dipole? The dipole acquires the position, axis of the dipole makes an angle theta with the direction of field. ಹಾಗಾದ್ರೆ so that is the ನೋಡಿ, so this is called as makes an angle is how much? So angle is equal to certain angle theta. ಹಾಗಾದ್ರೆ minus q, this is called as a plus q. So this is a dipole is makes an angle is theta. Assume that potential energy of the dipole to be 0. So potential energy of the dipole is 0 when theta is equal to 90 degree. The torque and potential energy of the dipole. However, what is the torque? So torque is equal to ಏನಿರುತ್ತೆ ಇಲ್ಲಿ PE sin theta. Okay, so PE sin theta. The potential energy, ನೋಡಿ, potential energy is 90 degree ನಲ್ಲಿ 0 ಇರುತ್ತೆ ಅಂತ ಹೇಳ್ತಾನೆ. It will be makes an angle theta, rotation theta. ಹಾಗಾದ್ರೆ theta 1 becomes, okay, so theta 1 ಏನಾಗುತ್ತೆ? So theta 1 becomes 90 degree and theta 2 becomes certain angle. ಹಾಗಾದ್ರೆ this is the potential energy. The potential energy is equal to how much? Minus PE cos theta. Okay, ಹಾಗಾದ್ರೆ which is the right answer? So this is a torque, this is the potential energy, PE sin theta minus PE cos theta. That is a option A is the right answer for the 25th question. Okay, 26th question. So 26th question anna nodi. The question is an electric dipole of momentum P angle is lying along the uniform electric field E. The work done in rotating the dipole by 90 degree anta helidane. So let's see the solution for the problem. First you have to draw this is called as the uniform electric field. Okay, hagadre in this uniform electric field you have, okay, electric dipole P is lying along in the uniform electric field. So this is a minus q, this is called as a plus q, this is along in the electric field dipole. The work is done to rotating for, you have to calculate what work done to rotating for how much degree? 90 degree anta kelidane. Okay, hagadre work done is equal to, so what is a formula for work done? That is work done is equal to minus PE cos theta 2 minus cos theta 1. What is theta 1 is here? Theta 1 is equal to 0 degree, theta 2 is equal to 90 degree. So now you have to put the value minus PE theta 2 cos 90. So what is cos 90? Cos 90 is 0 minus cos theta. So cos 0. What is cos 0? Cos 0 value is 1. So that is answer is equal to how much? So minus into minus plus PE, that is a option A is the right answer for 26th. So next move to the 27. So question number 27 anna nodi. So what is an electric dipole has magnitude of the charge Q. Okay, so this is a magnitude of the charge is Q. The dipole moment is P. It is placed on the uniform electric field E. If its dipole is along the direction of the field, the force on it and its potential energy respectively anta kelidane. So let's see the solution for the problem. So this is called as a uniform electric field. So in this uniform electric field ali, so where the dipole is placed, dipole is, so that is minus q and this is called as a plus q, this is a dipole direction, this is electric field. So if the dipole is along the direction of the field, okay, along the direction of the field means theta is equal to 0 degree. The force on it and its potential energy is respectively anta kelidane. Hagadre force is equal to, let's see, the electric field is starting from positive and terminated with negative. Negative and positive, this is a force is Fe, and this force is what? Fe. That is total nut force on the dipole. The nut force on the dipole becomes what? 0. Okay, so that is F is equal to 0. Nut force. Potential energy. Hagadre potential energy is equal to how much? The potential energy is equal to, so theta 1 is a 0 degree. Okay, so 0 degree, that means potential energy is equal to, what is a formula? Minus, okay, so minus PE. So potential energy, so if it's dipole moment along the direction of the field, the force on it and potential energy respectively. Potential energy ಏನಾಗುತ್ತೆ ಅಂತ ಕೇಳಿದಾನೆ ನೋಡಿ. potential energy 0 degree, so potential energy 0 ಅಂದ್ರೆ, so that is a minus PE cos theta formula. ಹಾಗಾದ್ರೆ potential energy is equal to minus PE cos 0 value is 1. okay, this is a negative side, ಹಾಗಾಗಿ energy ಏನಾಗುತ್ತೆ ಇಲ್ಲಿ? The energy becomes minimum. So ಹಾಗಾದ್ರೆ 0 and minimum, so that is option C. Okay, option C is the right answer for this question. So let's move to the next question. Question number 28. So what is the question number 28 is here. So 28, there is an electric field E in x direction. If the work is done to moving the charge point 2, so moving the charge is how much? It is a 0.2 coulomb through the distance of 2 meter along the line making an angle 60 degree with x-axis is 4 joule. What is the value of E anta kelidane? Okay, so let's see the solution for the problem. So you have to find out electric field. So electric field ana find out mana kelidane. So we know that is a potential energy is equal to minus PE cos theta. So energy and 4 joule. So 4 is equal to minus, that is a dipole is equal to Q into 2A. So charge estide anta heltane? Charge is 0.2. So 0.2 into distance 2A, 2 meter distance into electric field you have to find out, and cos theta, cos 60. So what is value of cos 60? Cos 60 is 1 by 2. So now 2 get cancelled, that is electric field is equal to, so minus is as it is, that is 4 divided by 0.2. Hagadre minus 4, so 2 into 10 to the power of plus 1. So that is answer is equal to, electric field is equal to minus 20 Newton per coulomb. So minus 20 Newton per coulomb. So which is the answer? That is a, then what is the value anta kelidane? Value is how much? That is a 20. Magnitude anna tagonda plus 20 agutte. That is a option B is the right answer for the 28. 29. So 29 question anna nodi. An electric dipole of dipole moment P is placed in the position of stable equilibrium. So look at the word, this is very important. Stable equilibrium nalli placement madidine anta heltane. In the what? Uniform electric field intensity E. If it is rotated through an angle theta from the initial position, the potential energy of the dipole in the final position anta keltane. So let's see the solution for the problem. This is called as a what? This is the electric field. So in this electric field, so you have to take the dipole. So stable dipole andre enagutte nodi. Stable means what? It is a minus q charge. This is called as a plus q charge. So electric field is starting from positive and terminated with negative. So these two are attracted. So this is a condition is called as what? stable equilibrium. Okay, ಹಾಗಾದ್ರೆ this is rotated to an angle theta from the initial position. ಇದು ಏನಾಗುತ್ತೆ, it will be rotated. Okay, rotated through an angle theta, the potential energy of the dipole of the final position ಅಂತ ಕೇಳಿದ್ದಾನೆ. Okay, ಹಾಗಾದ್ರೆ potential energy is equal to, what is a formula? That is minus PE cos theta 2 minus cos theta 1. This is the potential energy equation. So that is a, what is a theta 2 is here, first one is theta 1. So theta 1 is equal to, what is theta 1? It will be so theta 1 becomes how much? 0 degree. Theta 2 becomes theta certain angle. So the potential energy is equal to minus PE. What is cos theta 2? That is a cos theta minus cos 0. Cos 0 value is 1. So the potential energy is equal to, you have to take minus sign is common, minus into minus plus PE 1 minus cos theta. So which is the answer? PE 1 minus cos theta. That is a option B is the right answer for the 29. So question number 30. So question number 30 nodi, some charge is being given to the conductor. So this is a conductor. When the some charge is given to the conductor, okay, some charge is given to the conductor, then so nodi, that is electric field. The electric field is inside the conductor is equal to how much? 0. So electric field 0 adaga, that is E is equal to minus dV by dr. That is a dV is equal to ಏನಾಗುತ್ತೆ ಇಲ್ಲಿ constant. That means potential is what? Constant. So potential constant ಆಗ್ತಾ ಹೋಗುತ್ತೆ. Which is the answer? ನೋಡಿ, remains the same throughout the conductor. So then potential ಏನಾಗುತ್ತೆ ಇಲ್ಲಿ? Potential is remains same. Okay, so it is a remains same for the throughout the conductor. Okay, so that is option C is the right answer for what? This question, 30 question. So let's move to the next question, question number 31. Nodi, question number 31 anna nodana. Two metallic spheres, radii 1 centimeter and 3 centimeter are given the charges minus 1 into 10 to the power of minus 2 coulomb and 5 into 10 to the power of minus 2 coulomb respectively. So this is the first one is small sphere, then it is a larger sphere. Okay, two metallic spheres. This is the radius is 1 centimeter. So this radius is 3 centimeter. This is the small sphere, this is a bigger sphere. So this is a charge is minus 1 into 10 to the power of minus 2 coulomb, 5 into 10 to the power of minus 2 coulomb. So if these are connected by the connecting wire, okay, you have to connect it by the connecting wire. So wire ಮುಖಾಂತರ connect ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ? So when it is connected to the wire, the potential difference between the two spheres is same. Potential difference ಎರಡಕ್ಕೂ ಕೂಡ ಏನಾಗುತ್ತೆ ಇಲ್ಲಿ ಸೇಮ್ ಆಗುತ್ತೆ. ಹಾಗಾದ್ರೆ ಕಾಮನ್ ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್, ಸೊ ಕಾಮನ್ ಆಗಿರ್ತಕ್ಕಂಥ ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್ ಎಷ್ಟಾಗುತ್ತೆ ನೋಡಿ, ಕಾಮನ್ ಪೊಟೆನ್ಷಿಯಲ್. ಓಕೆ, ಸೊ ಕಾಮನ್ ಪೊಟೆನ್ಷಿಯಲ್ ದಟ್ ಈಸ್ ಎ V is equal to, what is a formula ನೋಡಿ, Q is equal to C into V. This is a formula. ಹಾಗಾದ್ರೆ V is equal to ಏನಾಗುತ್ತೆ, that is charge. Okay, so V is equal to charge divided by C. So charge means in the common potential, so charge is equal to ಏನಾಗುತ್ತೆ, Q1 plus Q2. Total charge divided by C1 plus C2. So capacitance, that is a C is equal to, so C is equal to ಏನಾಗುತ್ತೆ, that is a C is equal to 4 pi epsilon naught into R. So that is a capacitance in terms of radius. ಆದರೆ ನೋಡಿ charge, so this is minus 1 into 10 to the power of minus 2, 5 into 10 to the power of minus 2 ಎಷ್ಟಾಗುತ್ತೆ, that is a 4 into 10 to the power of minus 2. So this is a Q1 charge, this is a Q2 charge, these two are added. So 4 pi epsilon naught, ಇಲ್ಲಿ 4 pi epsilon naught is common, so radius, okay, so radius R1 R2, so R1 R2 radius ಏನಾಗುತ್ತೆ, so this is, these two are centimeter, so centimeter ನಲ್ಲಿ ಅಂದ್ರೆ, so that is equal to ಎಷ್ಟೈತಿ radius 1 plus 3 into 10 to the power of minus 2 in meter. Okay, so this is capacitance of the spherical capacitor formula. So now that is a potential, common potential is equal to, so common potential ಎಷ್ಟಾಗುತ್ತೆ ನೋಡಿ 4, so 3 plus 1 4, so this 4, this 4, this 10 to the power of minus 2, this 10 to the power of minus 2 get cancelled, that is a 1 by 4 pi epsilon naught. So adre question ಏನು ಕೇಳಿದಾನೆ, the final bigger charge, final charge, final charge, final bigger charge, so final bigger charge, so final bigger charge, so what is the bigger charge is here, bigger charge is Q2 dash after the wire connection, after the wire connect, after the wire connect, so Q2 dash is equal to, so that is a formula, we know that formula ಏನೈತಿ ನೋಡಿ, this is a C2, this one is C1, ಅಂದ್ರೆ bigger ಅಂದ್ರೆ C2 common potential difference, C2 into common potential difference. So C2 is what, 4 pi epsilon naught into bigger in radius 5 into 10, so bigger in the radius ಎಷ್ಟಾಯ್ತು ನೋಡ್ರಿ, bigger radius 3, so 3 into 10 to the power of minus 2 into common potential is 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught cancel, 3 into 10 to the power of minus 2 coulomb, that is a option B is the right answer for this question. So two metallic spheres, radii 1 centimeter and 2 centimeter given to the charge, okay, 10 to the power of minus 2 and 5 into 10 to the power of minus 2 coulomb respectively. If they are connected by the wire, the final charge on the small sphere. Okay, so same problem ana 31, okay, so 31 problem is as it is ide tara ide, so look at this one ನೋಡಿ 31 ಅನ್ನ ಲಾಸ್ಟ್ ಇದರಲ್ಲಿ ಸಾಲ್ವ್ ಮಾಡಿದೀನಿ, ಸೊ ಇದು 31 ಪ್ರಾಬ್ಲಮ್, ಓಕೆ, ಸೊ ಸೇಮ್ ಇದೇ ಒಂದು 31 ಪ್ರಾಬ್ಲಮ್ ಏನಿದೆನೋ, ಸೊ 32 ಪ್ರಾಬ್ಲಮ್ ಕೂಡ as it is ಇದೆ, you have to do for what, homework for the this problem. Okay, so let's move to the next problem, that is next problem is 33. So 33 problem ಅನ್ನು ನೋಡಿ, the electrostatic force between the metal plates and isolated parallel plate capacitor C having charge Q and area A. Okay, so this is called as a two metal sphere parallel plate, okay, sorry, parallel plate ivu, so parallel plates, capacitance ಎಷ್ಟೈತೆ ಇದ್ರದ್ದು C ಇದೆ and charge is how much, Q, area ಎಷ್ಟಿದೆ A. ಓಕೆ, ಸೊ ಹಾಗಾದ್ರೆ ಏನನ್ನ ಕೇಳಿದಾನೆ, ಎಲೆಕ್ಟ್ರೋಸ್ಟಾಟಿಕ್ ಫೋರ್ಸ್ ಅನ್ನ ಕೇಳಿದಾನೆ, ಓಕೆ, ಎಲೆಕ್ಟ್ರೋಸ್ಟಾಟಿಕ್ ಫೋರ್ಸು, ಸೊ ಎಷ್ಟು ಅದು ವ್ಯಾಲ್ಯೂ ಏನು ಅಂತ ಕೇಳಿದಾನೆ. ಹಾಗಾದ್ರೆ ಎಲೆಕ್ಟ್ರೋಸ್ಟಾಟಿಕ್ ಫೋರ್ಸ್ ಇಸ್ ಈಕ್ವಲ್ ಟು E into Q, ಓಕೆ, ಯಾಕಂದ್ರೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಫೋರ್ಸ್ ಬೈ ಚಾರ್ಜ್, ಫೋರ್ಸ್ ಇಸ್ ಈಕ್ವಲ್ ಟು E into Q. ಹಾಗಾದ್ರೆ ಎಲೆಕ್ಟ್ರೋಸ್ಟಾಟಿಕ್ ಫೋರ್ಸ್ ಇಸ್ ಈಕ್ವಲ್ ಟು So ನೋಡಿ, so it is q is as it is. What is the electric field? Electric field is equal to ಏನಿದೆ, sigma divided by 2 epsilon naught ಇದೆ. ಹಾಗಾದ್ರೆ electrostatic force is equal to q into 2 epsilon naught. So what is sigma? Sigma ಅಂದ್ರೇನು? Sigma is called as surface charge density. So charge divided by what? Area. Okay, so charge divided by area. ಹಾಗಾದ್ರೆ charge divided by area. So now electrostatic force is equal to q square divided by 2a epsilon naught. So there, so that is a electrostatic force is independent of the distance between the plates. Look at this one equation. So equation anna nodidaga it is surely independent of what? Distance. That is a option is the right answer. Linearly proportionality to the distance between the plates, then proportionality to the square root of distance between the plates, inversely proportionality to the distance between the plates. So which is the right answer for this question? That is electrostatic force is independent of the distance between the plates. Independent agide. That is option A is the right answer for this question. Next, question number 34. So question number 34 anna nodi, a parallel plate capacitor have capacity C and distance separation is D. So look at this one. This is called as a parallel plate. In this parallel plate alli enanta heltane avanu, so that is a C is a capacitance of capacity. So D is a distance between the plates, and potential difference V is applied between the plates. So V is the potential difference is applied between the plates. So now the question is what? Okay, so ಏನು ಕೇಳಿದಾನೆ ಅಂದ್ರೆ force of attraction between the plates of parallel plate. Force of attraction ಅನ್ನ ಕೇಳ್ತಾನೆ. So force of attraction is how much ಅಂತ ಹೇಳಿ. ಹಾಗಾದ್ರೆ force of attraction between the parallel plates, force of attraction is equal to the same formula. Force of attraction is equal to E into what? Q. So that is a F is equal to E means what? Sigma divided by 2 epsilon naught. So sigma divided by 2 epsilon naught andre, so that is equal to, now you have to do the simplification. That is just one answer, Q square divided by A epsilon naught. This is the force is equal to just one to Q square divided by A epsilon naught. So but ಆ ಪ್ರಾಬ್ಲಮ್ ಈ ಪ್ರಾಬ್ಲಮ್ ಏನಂತ ಡಿಫರೆನ್ಸ್ ಕೇಳಿದಾನೆ ಅಂದ್ರೆ ನೋಡಿ, ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್ V ಅಂತಕ್ಕಂಥದ್ದು ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್ ಅನ್ನ ಕೇಳಿದಾನೆ. ಸೊ ನೆಕ್ಸ್ಟ್ ಯು ಹ್ಯಾವ್ ಟು ಗೋ ಟು ದ ಒನ್ ಮೋರ್ ಸ್ಟೆಪ್. ಸೊ ಹಾಗಾದ್ರೆ ಏನಪ್ಪ ಅಂದ್ರೆ Q is equal to what? C into B. ಪೊಟೆನ್ಷಿಯಲ್ ಡಿಫರೆನ್ಸ್ ಅನ್ನು ಅಪ್ಲೈ ಮಾಡಿದೀನಿ ಅಂತ ಆದ್ರೆ, ಸೊ ನಾವು ಸೊ ದಿಸ್ ಬಿಕಮ್ಸ್ ಏನಾಗುತ್ತೆ, ದಟ್ ಈಸ್ ಎಲೆಕ್ಟ್ರೋಸ್ಟಾಟಿಕ್ ಫೋರ್ಸ್ is equal to C square V square divided by A epsilon naught. Okay, so A epsilon naught. So C, A epsilon naught. C is equal to A epsilon naught by D. In the place of A epsilon naught, you have to put what? C into D. So that is C square V square divided by C into D. 1C get cancelled. So that is a answer is equal to how much? CV square divided by D. So CV square divided by D is 2 ide, that is 2. So CV square divided by 2D, which is the right answer? CV square by 2D. That is a option D is the right answer for this question. So let's move to the a parallel plate A is charged with the potential difference is V volts. So let's see, this is called as a capacitor. So two diagram. Okay, so the first one is, it is a air. Okay, a parallel plate capacitor charged with the potential difference is V volt. Potential difference is V volt. So potential difference anna V volt anna apply ಮಾಡಿ ಬಿಡ್ತಾನೆ. ಆದರೆ after disconnecting the charging of the battery, okay, now so on the distance, this is the distance is d. So distance ಅನ್ನ ಏನು ಮಾಡ್ತೀನಿ ಅಂತ ಹೇಳ್ತಾನೆ ಅವನು. So distance between the plates of the capacitor is increased. Okay, so the distance is increases. So the distance between the plates anna increases ಮಾಡ್ತೀನಿ ಅಂತ ಹೇಳ್ತಾನೆ. So now it is a disconnected from the battery. So battery ಇಂದ ಏನಾಗಿತ್ತಿದು disconnect. Okay, so disconnect. So now as the result, potential difference between the plates, potential difference is V is equal to question mark. So let's see the solution. Nodi, first one is capacitance of parallel plate capacitor is equal to A epsilon naught by D. C is inversely proportionality to the D. So distance anna increases ಮಾಡ್ತೀನಿ ಅಂತ ಹೇಳ್ತಾನೆ. So therefore distance is increases, capacitance is decreases. So capacitance ಏನಾಗುತ್ತೆ, capacitance is decreases. So capacitance decreases ಆಗುತ್ತೆ. So next ಇಲ್ಲಿ ಏನು ಮಾಡ್ತೀನಿ ಅಂತ ಹೇಳ್ತಾನೆ ನಾನು, you have to disconnect. So disconnect ಮಾಡಿದ್ದೀನಿ ಅಂತ ಹೇಳಿದ್ರೆ disconnect means the charge is becomes ಏನಾಗುತ್ತೆ, ಇಲ್ಲಿ ಸೇಮ್ ಇರುತ್ತೆ ಚಾರ್ಜ್. ಸೊ ಅಂದ್ರೆ ಚಾರ್ಜ್ ಸೇಮ್ ಆಗಿದ್ರೆ Q is equal to C into V, then C is equal to Q by V. So charge is remains same ಆದರೆ then C is proportionality to the V. So C is decreases. So C is decreases ಆದರೆ V is what, increases. Then potential difference is what, increases. That is a option A is the right answer for this question. So next question, question number 36. The capacitance of the parallel plate capacitor with air medium is 6 microfarad. Okay, so this is called as a capacitance of parallel plate capacitor. So in this capacitance of parallel plate capacitor, that is a first one is what, it is a air medium. So air medium into that is called as air medium is 6 microfarad. So with introduce the dielectric medium. So this is a dielectric medium anna, so introduce ಮಾಡ್ತೀನಿ ಅಂತ ಹೇಳ್ತಾನೆ. So this is called as a dielectric medium. So this dielectric medium is introduced, that is the capacitance of the medium is equal to 30 microfarad. The permittivity of the medium, you have to calculate permittivity of the medium. So we know that is a dielectric constant is equal to, that is capacitance of medium divided by capacitance of what, air. So that is equal to, that is a 630 microfarad divided by 6 microfarad. So microfarad cancel, 6 1 ja 6 5 ja, that is equal to dielectric constant is equal to 5. So dielectric constant 5 bandre, that is dielectric constant is equal to epsilon divided by epsilon naught. Okay, so we know this equation in the first electric charges and field chapter. This is called as relative, that is a permittivity of medium. The permittivity of medium is equal to K into epsilon naught. So now you have to do the simplification, is equal to K is 5 into epsilon naught value is 8.85 into 10 to the power of minus 12. So what is the answer for this question? The answer is equal to 0.44 into 10 to the power of minus 10. So that is a option C is the right answer for 36th question. Okay, so 36th question again, that is option C. Next 37. Okay, so next question nodana 38. Okay, so 38 question, 37 ನೋಡಿ 37 ಅನ್ನ you have to already studied in theory part ಅಲ್ಲಿ ನಾವು ಓದಿರ್ತೀವಿ ಇದನ್ನ. Okay, so theory part ಅಲ್ಲಿ ಓದಿರ್ತೀವಿ, that is a option C is the right answer. Okay, so 38. So 38 question ನೋಡಿ. That is a two parallel metal plates having the charges plus q and minus q face on each other at a certain distance between them. So this is a two parallel plates. So these two parallel plates ali you have to, this is a plus q and this one is called as minus q at the certain. If the plates are now dipped with the kerosene tank, okay, so these plates anna you have to fix it with the kerosene medium tank. The electric field of the plate anta keltane. Electric field enagutte? So what is the electric field? So nodi, that is a capacitance in air is equal to A epsilon naught divided by what? D. So what is the capacitance in medium? Medium is equal to K A epsilon naught divided by what? D. So now that is a capacitance of air is equal to what? Capacitance of medium divided by K. So now that is the answer for this one. So capacitance, okay, so ಇಲ್ಲಿ ನೋಡಿ, that is electric field. Okay, so ಇಲ್ಲಿ electric field ಎಷ್ಟಿರುತ್ತೆ? That is a sigma divided by epsilon naught ಇರುತ್ತೆ. ಸೊ ಇಲ್ಲಿ electric field ಏನಾಗಿರುತ್ತೆ? Sigma divided by k epsilon naught ಇರುತ್ತೆ. ಸೊ ಸಿಂಪಲ್ ಆಗಿ ಈಕ್ವೇಶನ್ ಅನ್ನು ತಗೊಂಡು ನೋಡಿ ಇವೆರಡನ್ನು. ಹಾಗಾದ್ರೆ ಏನಾಗುತ್ತೆ? That is a air medium, this is called as a kerosene medium. ಸೊ ಅದೇ ಏರ್ ಮೀಡಿಯಂ ನಲ್ಲಿ ಜಾಸ್ತಿ ಇರುತ್ತೆ. ಹಾಗಾಗಿ ಏನಾಗುತ್ತೆ ಆನ್ಸರು? ದ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಅಷ್ಟೇ ಕೇಳಿದಾನೆ. ಸೊ ಇವು ಮಾಡೋ ಅವಶ್ಯಕತೆ ಇರೋದಿಲ್ಲ, ಡೈರೆಕ್ಟ್ ಆಗಿ ಆನ್ಸರ್ ಎರಡೇ ಸ್ಟೆಪ್ಸ್ ಬಂದ್ಬಿಡುತ್ತೆ. ಹಾಗಾದ್ರೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಡಿಪ್ಡ್ ಇನ್ ದ ಕೆರೋಸಿನ್ ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ? ಕೆರೋಸಿನ್ಗೆ ಹಾಕಿದಾಗ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಏನಾಗುತ್ತೆ? ಇಲ್ಲಿ ಡಿಕ್ರೀಸಸ್ ಆಗುತ್ತೆ. ದಟ್ ಈಸ್ ಎ ಆಪ್ಷನ್ ಸಿ ಇಸ್ ದ ರೈಟ್ ಆನ್ಸರ್ ಫಾರ್ ದಿಸ್ ಕ್ವಶನ್. ಓಕೆ, ಸೊ ಇದನ್ನೇನಾದ್ರೂ ನಾವು ಏನ್ ಮಾಡ್ಬೋದಾಗಿತ್ತು? ಸೊ ಕೆಪಾಸಿಟನ್ಸ್ ಏನಾಗುತ್ತೆ ಅಂತ ಕೇಳಿದ್ರೆ ಈ ಒಂದು ಫಾರ್ಮ್ಯಾಟ್ ನ ತಗೊಂಡು ಮಾಡಬೇಕಾಗ್ತಿತ್ತು. ಸೊ ಬಟ್ ಅವ್ನು ಈಸಿಯಾಗಿ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಅನ್ನ ಅಷ್ಟೇ ಕೇಳಿದಾನೆ. ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ? ಸೊ ಇಲ್ಲಿ ಏರ್ ಮೀಡಿಯಂ ನಲ್ಲಿದ್ದು ಇದಕ್ಕೆ ಹೋದಾಗ, ಸೊ ಕೆರೋಸಿನ್ ಮೀಡಿಯಂಗೆ ಹೋದಾಗ ಏನಾಗುತ್ತೆ? ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಡಿಕ್ರೀಸಸ್ ಆಗುತ್ತೆ. ಸೊ ಎಷ್ಟು ಡಿಕ್ರೀಸಸ್ ಆಗುತ್ತೆ ಅಂದ್ರೆ k ಟೈಮ್ಸ್ ಡಿಕ್ರೀಸಸ್ ಆಗುತ್ತೆ. Question number 39. A parallel plate condenser with oil between the plates. So this is called as a plates. Hagadre dielectric constant is equal to 2. Capacitance is C. If the oil is removed, then the capacitance of capacitor becomes. Okay, so oil anna remove ಮಾಡುತ್ತೆ ಅಂದಾಗ, oil anna remove ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ? ಇಲ್ಲಿ air. What is the capacitance of air medium is question mark. So last ಅಲ್ಲಿ ಮಾಡಿದ್ವಿ, that is capacitance is equal to, okay, so capacitance is equal to formula ಏನ್ ಮಾಡಿದ್ವಿ ನೋಡಿ, ಲಾಸ್ಟ್ ಒಂದು ಪ್ರಾಬ್ಲಮ್ ನಲ್ಲಿ ಮಾಡಿದ್ವಿ. So that is a capacitance in medium divided by capacitance of what? air. ಹಾಗಾದ್ರೆ capacitance of air ಬೇಕಾಗಿದೆ, capacitance of medium by k. capacitance of medium ನಲ್ಲಿ ಎಷ್ಟಿದೆ? that is a C. ಕೆಪಾಸಿಟನ್ಸ್ ಎಷ್ಟಿದೆ ಇದರಲ್ಲಿ? ಸೊ C ಇದೆ. ಸೊ ಡೈಎಲೆಕ್ಟ್ರಿಕ್ ಕಾನ್ಸ್ಟೆಂಟ್ 2 ಇದೆ. ಆದರೆ C by 2, that is a option D is the right answer for the 39 question. ಸೊ ನೆಕ್ಸ್ಟ್ 39 ಆಯ್ತು, 40 ಕ್ವಶನ್ ನೋಡಿ. 40 ಕ್ವಶನ್ ಏನಿದೆ? ಸೊ ದಿಸ್ ಇಸ್ ಎ ಕ್ವಶನ್ ನಂಬರ್ 40. ಸೊ ಕ್ವಶನ್ ನಂಬರ್ 40 ಅಲ್ಲಿ ಏನಿದೆ ಅಂದ್ರೆ, a parallel plate capacitor area A and plate is a separation with what? D and capacitance is C is filled with the 4 dielectric materials having the dielectric constant is K1, K2, K3, K4 as shown in figure. If the single dielectric material is to be used to have the same capacitance C in this capacitor, then the dielectric constant is ಅಂತ ಕೇಳಿದಾನೆ. ಓಕೆ, ಡೈಎಲೆಕ್ಟ್ರಿಕ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಅನ್ನು ಸೊ ಕೆ ಅನ್ನು ಫೈಂಡ್ ಔಟ್ ಮಾಡಿ ಅಂತ ಕೇಳಿದಾನೆ. ಸೊ ಹಾಗಾದ್ರೆ ಡೈಎಲೆಕ್ಟ್ರಿಕ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಅನ್ನು ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕಾದ್ರೆ ಫಸ್ಟ್ ಒನ್ ನೋಡಿ. ಸೊ ದಟ್ ಈಸ್ ಎ ಕೆಪಾಸಿಟನ್ಸ್ formula. So that is capacitance C is equal to K A epsilon naught divided by D. So this is a basic formula. Illinda basic inda start madana. Hagadre first one. So this one is called as what? C1, C2, C3. This one is called as C4. Okay. So C1 ಏನಾಗುತ್ತೆ ನೋಡಿ. C1 is equal to dielectric constant ಎಷ್ಟಿದೆ? K1. Area ಎಷ್ಟಿದೆ? A by 3. Okay. A by 3. So then epsilon naught divided by D. So D distance ಎಷ್ಟಿದೆ ಅಲ್ಲಿ? D by 2. This is D by 2. So now you have to do that is 2K1 A epsilon naught divided by ಎಷ್ಟಾಗುತ್ತೆ? 3D. Similarly C2 is equal to ನೋಡಿ. So C2 is equal to, so ಇದು ಕೂಡ D by 2 and A by 3 ಸೇಮ್ ಇದೆ. ಹಾಗಾದ್ರೆ so this one is also ಏನಾಗುತ್ತೆ? ಇದು C2. So C2 ಇಲ್ಲಿ K2 ಆಗುತ್ತೆ. 2K2 A epsilon naught divided by 3D. So C3 is equal to 2K3 A epsilon naught divided by 3D. So C1, C2, C3, then you have to C4. Okay, ಹಾಗಾದ್ರೆ C4 ಅನ್ನು ನೋಡಿ. So C4 is equal to, so K4 ಆಗುತ್ತೆ. K4, what is A? Area of cross section is ಎಷ್ಟಿದೆ? A ಇದೆ. A epsilon naught divided by D. So ನೋಡಿ D, so this is the distance, total distance ಇದಾದ್ರೆ D by 2 ಅಂದ್ರೆ 2D. So this is C4. Now so C1, C2, C3. So what is the connection is here? So ನೋಡಿ connection ಏನಾಗುತ್ತೆ? So this becomes C1. So this becomes C2. So this becomes C3. Okay, ನೋಡಿ C1, C2, C3. So these are connected in parallel. So parallel with ಈ connection ಯಾವ್ದು ಬರ್ತದೆ? ಇದು series. So C1, C2, C3, this is connected with what? C4. So this is a parallel connection. So parallel connection ಅಂದಾಗ ನೋಡಿ, so parallel ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ formula? So that is parallel when capacitors are connected. So parallel ಇದ್ದಾಗ that is CP is equal to C1, C2, C3. So C1, C2, C3 ನೋಡಿ, C1, C2, C3. So ಎಲ್ಲದರಲ್ಲಿ ಕಾಮನ್ ಏನು ಬರುತ್ತೆ? that is 2A epsilon naught divided by 3D is the common. So remaining ಏನು ಉಳಿಯುತ್ತೆ? K1 plus K2 plus what? K3. So this is called as a CP. ಅಂದ್ರೆ ಇದು parallel. ಇದಿಷ್ಟು ಸೇರಿ ಒಂದು ಕೆಪಾಸಿಟರ್ ಆಯಿತು. So then CP, this one is C4. So these are connected in final ಆಗಿ C equivalent is equal to, so this one. So ಇದನ್ನ reciprocal ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ ನೋಡಿ, reciprocal ಮಾಡಿದಾಗ 3D divided by 2A epsilon naught divided by ಏನಾಗುತ್ತೆ? So this becomes K1 plus K2 plus K3. Okay, so reverse ಅಲ್ಲಿ ಮಾಡಿದಾಗ, so this is called as 1 by C1. ಯಾಕಂದ್ರೆ series connection ಏನಾಗುತ್ತೆ? series is equal to 1 by C1 plus 1 by C2. so ಹಾಗಾಗಿ ರಿವರ್ಸ್ ಮಾಡಿದ್ದೀನಿ. ಪ್ಲಸ್ so C4 ಅನ್ನು ನೋಡಿ, 4 ಏನಾಗುತ್ತೆ? D divided by 2K4A epsilon naught. So now we have to do the calculation. So calculation ಮಾಡಿದಾಗ so ಏನಾಗುತ್ತೆ ಆನ್ಸರ್? that is the C is the answer. okay, so C ಅಂತಕ್ಕಂಥದ್ದು ಆನ್ಸರ್ ಬರುತ್ತೆ ನೋಡಿ ಇದರಲ್ಲಿ. ಓಕೆ, ಕಾಮನ್ ಅನ್ನು ತೆಗಿರಿ. ಸೊ ಕಾಮನ್ ಅನ್ನು ತೆಗೆದು ಸಿಂಪ್ಲಿಫಿಕೇಶನ್ ಮಾಡಿದಾಗ ಆಪ್ಷನ್ C is the right answer for this question. So let's move to the question number 41. So question number 41 ಅನ್ನು ನೋಡಿ. So 3 capacitors, each capacitance is C and breakdown voltage is V are joined in the series, the capacitance and the breakdown voltage of the combination will be anta kelidane. Okay, ಹಾಗಾದ್ರೆ 3 capacitors. So this is a 3 capacitors. Capacitance is C and breakdown voltage is V. So the capacitance will be, so capacitance ಏನಾಗುತ್ತೆ, that is C equivalent is equal to, so C equivalent is equal to ಏನಾಗುತ್ತೆ, C by 3. So ಹೇಗೆ ಫಾರ್ಮುಲಾ ನೋಡಿ, 1 by C plus 1 by C plus 1 by C. So that is equal to 3 by C ಅಂದ್ರೆ C by 3 ಬರುತ್ತೆ. So this is C equivalent. What is the breakdown voltage? Nodi, that is a breakdown voltage. So voltage is equal to, what is a formula, that is Q by C. Q divided by C equivalent. C equivalent estide alli C by 3. So that is equal to 3Q divided by C. So what is the answer? Nodi, C by 3. So C by 3, 3Q by C. So what is a Q by C? Q by C andre enagutte, that is Q by C. Q by C is equal to what? V. Okay. So which is the right answer? C by 3, 3V. That is a option B is the right answer for the 41. So let's move to the 42 question. Nodi 42 question anna yav tara ide. So the 42 question. A network 4 capacitor of capacity equal, that is a C1, C2, C3 and C4, okay, are connected in the battery as shown. The ratio of C2 and C4 anta kelidane. So C2 and C4 anna find out madak kelidane. So let's see the solution for the problem. So nodi first one, so this is a C1, C2, C3. These three are connected in what? Series connection. So series adralage enagutte, 1 by C equivalent is equal to 1 by C1C plus 1 by 2C plus 1 by 3C. So that is equal to LCM estagutte, 6C. So 6 plus 3 plus 2. So then C equivalent is equal to 6C divided by 11. Okay, then the charge on the C1, C2, C3. So what is the charge on C1, C2, C3? The charge. Okay, so ಏನು ಕೇಳಿದಾನೆ ಅವನು, the ratio of charges ಅನ್ನು ಕೇಳಿದಾನೆ. Q2 ಮತ್ತು Q3 charges, Q4. The charge on Q1, Q2 and Q3 series connection ಇದ್ದಾಗ charges remains same. Okay, so this charge becomes ಏನಾಗುತ್ತೆ, Q2 charge becomes C dash ಅಂದ್ರೆ C equivalent into V. So ಹಾಗಾದ್ರೆ C equivalent ಎಷ್ಟಿದೆ, 6 by 11 into C. This is a C equivalent into V. So that is 6 by 11 CV. So Q2 charge. Then what is the charge on Q4? ನೋಡಿ Q4 ನಲ್ಲಿ charge ಎಷ್ಟಾಗುತ್ತೆ? So C capacitance ಎಷ್ಟಿದೆ ಇಲ್ಲಿ ನೋಡಿ, 4C into what? V. Okay, then charge ratio Q2 divided by Q4. So Q2 ಎಷ್ಟಿದೆ, that is a 6CV divided by 11 into Q4 in ಎಷ್ಟಿದೆ, that is 1 divided by 4CV. CV get cancelled, 2 2s and 2 3s. So what is the answer? 3 by 22. So that is option B is the right answer for the 42 question. So let's move to the question number 43. So question number 43 anna nodi, 3 capacitors, each capacity is 4 microfarad, are connected in such way that effective capacitance is, so 6 microfarad. This combined will be, all are in series. Series allagdaga enagutte formula. So if same capacitors are connected in series, that is C by 3. So C by 3 andre that is 4 by 3. So 4 by 3 barutte equivalent. Adhe equivalent test barbeku, C equivalent is equal to 6 microfarad barbeku. Idu 4 by 3 barutte. That is wrong answer. So parallel connection ಏನಂತೆ C1 plus C2 that is equal to 8 microfarad. ಹಾಗಾದ್ರೆ parallel ಅಲ್ಲಿಲ್ಲ. So connecting two are in series. So first two are connected in series. Okay, so series, and then another one is what? Parallel. Okay, so let's see the answer. This is a 4 4 4. So series connection allidaga enagutte? So that is C by 2. C by 2 andre 4 by 2. So 4 by 2 ಎಷ್ಟು ಬರುತ್ತೆ ಇಲ್ಲಿ? That is 2 microfarad. So 2 microfarad, this one is called as what? 4 microfarad. Okay, so these two are connected in parallel andaga, that is a C equivalent is equal to C1 plus C2. So C1 plus C2 andre 4 plus 2. So 4 plus 2 becomes 6 microfarad. C equivalent is equal to 6 bandide. That is a option C is the right answer for the 43 question. 44 question. So question number 44 ಅನ್ನು ನೋಡೋಣ. ನೋಡಿ ಏನಿದೆ question number 44. A capacitor of capacity C1 is charged up to the V volts and then connected in parallel to an uncharged capacitor of capacity C2. The final potential difference will be ಅಂತ ಕೇಳಿದ್ದಾನೆ. Okay, so ಹಾಗಾದ್ರೆ final potential difference ಅನ್ನ ಏನಾಗುತ್ತೆ? First one, the charge. Okay, so the charge on the first capacitor. Charge on the first capacitor. So what is the charge on the first capacitor? That is a charge on the first capacitor is equal to C1V. ಯಾಕಂದ್ರೆ capacitance C1 ಇದೆ, ಇದು V volt ಇದೆ. What is the charge on second? That is a charge on the second capacitor. Second capacitor, ನೋಡಿ, then connected parallel to the uncharged capacitor. Uncharged capacitor ಅಂದ್ರೆ Q2 becomes ಎಷ್ಟಾಗುತ್ತೆ? 0. It is a why? Because Q1 uncharged capacitor. So then total charge is equal to Q is equal to Q1 plus Q2, that is equal to C1V. So capacitors are then connected in what? ಏನಂತ ಹೇಳ್ತಾನೆ? Parallel. So parallel connection. So parallel ಅಂದಾಗ CP is equal to C1 plus ಏನ್ ಬರುತ್ತೆ ಇಲ್ಲಿ? C2. So common potential difference. So common potential difference ಏನ್ ಬರುತ್ತೆ? ನೋಡಿ, common potential difference is equal to Q divided by C parallel. So Q ಎಷ್ಟಿದೆ? Capital Q. Total capacity, total charge capital Q divided by Cp. So capital Q divided by Cp. ಹಾಗಾದ್ರೆ total charge ಎಷ್ಟಿದೆ? C1V divided by parallel ಎಷ್ಟಿದೆ? C1 plus C2. So final potential is equal to how much? C1V divided by C1 plus C2. That is a option B is the right answer for the 44. Okay, next move to the question number 45. So question number 45, the effective capacitor between X and Y ಅಂತ ಕೇಳ್ತಾನೆ. So X and Y, you have to 1 2 3, you have to come to the point of Wheatstone bridge. So Wheatstone bridge ಬರೋಣ ನೋಡಿ. So this is called as Wheatstone bridge. So this is called as a Wheatstone bridge. Okay, ನೋಡಿ complete ಮಾಡೋಣ. So this is a Wheatstone bridge. So this is X, Y, A, B, C, D. So A is connected to the B. So A in the B ಎಷ್ಟಿದೆ? 6. A in the B ಗೆ 6 microfarad. So this is completed. A to the C again 6. A to the C 6 microfarad. C to the B. So C to the B, so this is how much? 20 microfarad. B to the D, this is also 6 microfarad, so this is 6. So C to the D 6 microfarad. ನೋಡಿ it is a Wheatstone bridge. Wheatstone bridge ಅಂದ್ರೆ Q1 Q2 Q3 Q4 ಹಾಗಾದ್ರೆ then Q1 by Q2 is equal to Q3 by Q4 satisfied ಆಗುತ್ತಾನೋ? 6 by 6 is equal to 6 by 6, so that is satisfied. So ಯಾವಾಗ ಇದು satisfied ಆಗುತ್ತೋ you have to remove this central connection. So central connection ಅನ್ನು remove ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ? These two are connected in series. Okay, so ಹಾಗಾದ್ರೆ ಇವೆರಡು series connection ಆಗುತ್ತೆ. So then these two are connected in series. So series ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ? 6 by 2, that is called as 3 microfarad. So this one is called as 3 microfarad. So these two are connected in parallel. Parallelly C1 plus C2. So 3 microfarad plus 3 microfarad. So that is the answer is 6 microfarad. That is option D is the right answer for this question. Wheatstone bridge concept nalli ಇದೆ. This is called as common potential. Okay, so common potential appa anta ಹೇಳಿದ್ರೆ. Okay, so question number 46 ನೋಡಿ. Two identical capacitors C1 and C2 of equal capacitance are connected as shown in the circuit diagram. So terminals A and B are connected with what? Plug key. Okay, so hagadre plug key inda connect madidare. So now this is a connected. So hagadre this charge is capacitor. Okay, hagadre what is the initial energy stored in the capacitor? That is equal to 1 by 2 CV square. This is the initial energy stored in the capacitor. So now the question is continue ಆಗುತ್ತೆ ಮತ್ತೆ. So ಹಾಗಾದ್ರೆ ಏನು ಹೇಳ್ತಾನೆ ಮತ್ತೆ? Using the battery EMF. Now okay, now disconnect A and B. So A and B ಅನ್ನ disconnect ಮಾಡ್ತೀನಿ ಅಂತ ಹೇಳ್ತಾನೆ. ನೋಡಿ A and B ಅನ್ನ disconnect ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ? So this is the, so completely it is a disconnected, as ಇಲ್ಲಿ completely so energy store ಆಯ್ತು. So now this is then connected. Okay, so ಇದನ್ನ next connect ಮಾಡ್ತೀನಿ ಅಂತ ಹೇಳ್ತಾನೆ. So ಅದೇ this capacitor said to be charge. Okay, so ಇದು charge ಆಗುತ್ತೆ. ಹಾಗಾದ್ರೆ what is the percentage of loss of energy ಅಂತ ಕೇಳಿದಾನೆ. ಹಾಗಾದ್ರೆ so loss of energy. Okay, so loss of energy. So what is the formula for loss of energy? That is change in the potential energy divided by initial potential energy into 100. It is a percentage of what? So loss of energy. Okay, so this is the loss of potential energy. So now hagadre so initial energy is equal to how much? Initial energy is equal to half CV square ಇದೆ. ಹಾಗಾದ್ರೆ that is called as change in energy is equal to, so change in energy is equal to, so what is the formula? That is 1 by 2 C1 C2 divided by C1 plus C2 into what? V square. So this is called as a change in energy. So that is equal to 1 by 2. So identical. So identical andre, so this is values are same. ಹಾಗಾದ್ರೆ C into C square divided by 2C into V square. So ಹಾಗಾದ್ರೆ that is the change in the energy is equal to how much? So 1C get cancelled. So that is 1 by 2 into 1 by 2. So C V square. So now you have to put the value, that is so loss of energy. So loss of energy is equal to how much? ನೋಡಿ ಎಷ್ಟು ಲಾಸ್ ಆಗುತ್ತೆ ಎನರ್ಜಿ ಅಂದ್ರೆ change in energy ಎಷ್ಟು ಬಂತು? So that is 1 by 2 CV square. So this is change in energy divided by So initial energy ಎಷ್ಟಿದೆ 1 by 2 CV square. So into 100%. So 1 by CV square, 1 by CV square cancel. So that is equal to how much answer? 50%. That is a option C is the right answer for the 46th question. So let's move to the next question, 47 question. So 47 anna nodi, a capacitor is charged by the battery. Okay, so this is called as a capacitor. So this capacitor is charged by the battery. Okay, so this is a charged by the battery. The battery is removed. So next step en martane. So it is a initial energy. What is the initial energy storage? 1 by 2 CV square. This is the initial energy. So hagadre next en martane. So another identical. Okay, another identical uncharged capacitor. So this is the first capacitor, then another uncharged capacitor. This is another uncharged capacitor. So is connected in parallel. The total electrostatic resulting in the system. Alright. So this is a concept is also enagutte loss of energy. So the loss of energy is equal to what is a formula? That is change in energy divided by initial energy into 100%. Alright. So that is loss of energy is equal to. So loss of energy is equal to what is change in energy? So you have to calculate change in energy. So change in energy Ui minus Uf is equal to what is a formula? 1 by 2 C1 C2 divided by C1 plus C2 V square. So that is equal to 1 by 2 Cc. So that is identical. This capacitor is Cc. Hagadre enagutte C square divided by 2C into V square. So that is equal to how much? 1 by 2 CV square. So now that is change in energy is equal to how much? That is 1 by 2 CV square divided by initial energy is how much? 1 by 2 CV square. So now 1 by 2 CV square, 1 by 2 CV square is cancelled. So that is equal to how much? It is a 50%. What is the loss of energy? 50%. 50% means initial energy is E adre. So what is 50%? That is E by 2. So that is what is the decreases by the factor? Decreases by the factor is 2. That is a option A is the right answer for 47. 48 question. Okay, 48 anna nodi, a parallel plate air capacitor of capacitance C is connected to the cell of EMF E. So this is a parallel plate capacitor. So this parallel plate capacitor is connected to the what? V volt supply. And then disconnected from it a dielectric slab. So then it is disconnected. So then it is a dielectric slab is introduced between the plates. Okay, so now the dielectric slab is introduced between them. So this is called as a dielectric slab. So this dielectric slab is introduced between them. The dielectric constant is K. So now which of the following is incorrect? Okay, which of the following is incorrect? So then that is initial energy is equal to 1 by 2 CV square. So but potential is connected to the EMF. So V is equal to Q by C. So now you have to put the value of 1 by 2 in the place of V. So V plus electrostatic, that is Q square divided by C square. So now that is initial energy is equal to 1C get cancelled. 1 by 2 Q square divided by C. So then you have to come to the point of dielectric. So dielectric anna introduce madadaga enagutte, that is final energy is equal to 1 by 2 Q square. Okay, C into n agutte illi K. So why? Dielectric constant is equal to Cm by Ca. So ಹಾಗಾದ್ರೆ Cm ಇದು ಮೀಡಿಯಂ ಆಗಿರುತ್ತೆ, K ಕನ್ವರ್ಟ್ ಮಾಡಿದಾಗ C into K ಆಗುತ್ತೆ. Okay, ಹಾಗಾದ್ರೆ then that is a change in the energy. The change in energy is equal to final. So final minus initial. So now we have to common factor. So Q square 2C and a common factor. So that is 1 by K minus 1. So that is change in energy is equal to, so Q place ali you have to what put? So in the Q ali Vc. So that is 1 by 2. So C square V square divided by C into 1 by K minus 1. So 1C get cancelled. That is 1 by 2 CD square 1 by K minus 1. So this is a what? It is a correct statement. The potential difference between the plates is decreases by K. Nodi, potential difference ಏನಾಗುತ್ತೆ? So this potential, when the dielectric stab is introduced, the potential is decreases by K times. This is also correct statement. The energy stored in the capacitor decreases by K times. So this is a energy is also decreases by K times. This is also correct. So which is the right answer? That is a option B. It is a, okay, the energy of the capacitor is incorrect. So this is a what? Incorrect statement. So that is option B is the right answer for the part. Okay, so let's move to the next question. So next question 49. So 49 question anodi, a parallel plate capacitor has uniform electric field E. So this is the uniform electric field